Imagine a world where you could travel to a distant star and return home to find your identical twin much older than you are. Sounds like science fiction, right? Well, this mind-bending concept is not only real, but it is also a direct consequence of Albert Einstein's theory of special relativity. The twin paradox simply states that if one of a pair of twins travels at very high speeds through space and then returns, that traveling twin will have aged less than the twin who remained on Earth. It is not a paradox in the sense of a logical contradiction, but rather a thought experiment that highlights how our everyday intuition about time can be misleading when dealing with extreme velocities. The core reason for this surprising phenomenon lies in something called time dilation. Einstein's special relativity tells us that time is not an absolute constant, but rather it passes differently for observers in relative motion. Crucially, the paradox is resolved because the traveling twin undergoes acceleration and deceleration when leaving, turning around, and returning to Earth. This means the traveling twin changes their inertial reference frame, while the stay-at-home twin remains in a single, consistent inertial frame on Earth. It is this difference in experiences, particularly the acceleration, that makes their timelines diverge. While we do not notice time dilation in our daily lives, because our speeds are so slow compared to the speed of light, this effect is measurable. Precise atomic clocks aboard spacecraft, like those on the International Space Station, run slightly slower than identical clocks on Earth. Astronauts on long missions return having aged a tiny fraction of a second less than if they had stayed home, demonstrating the real-world utility of understanding this concept. The faster and longer the journey, the more significant the age difference would become. Think of it this way: each twin experiences their own personal time, often called proper time, ticking away perfectly normally for themselves. The traveling twin does not feel time slowing down. For them, everything proceeds as usual. The difference only becomes apparent when their two timelines are compared upon reunion. It is a testament to the elegant yet counterintuitive nature of spacetime itself, showing that motion through space inherently affects one's motion through time. Ultimately, the twin paradox helps us grasp that time is not a universal, fixed clock for everyone, but rather a dynamic dimension intricately linked with motion and gravity. It is a powerful illustration of how the universe truly works, revealing the profound interconnectedness of space and time, and offering a deeper appreciation for the physics that governs our existence.